For most of modern astronomy, Pluto was treated like a distant afterthought. Once celebrated as the ninth planet, it was reclassified in 2006 by the International Astronomical Union as a dwarf planet. To many, it felt like a quiet demotion, a removal from the family of major worlds. Pluto became, in popular imagination, a frozen leftover drifting at the edge of the sun's reach. But science has a way of rewriting first impressions. In 2015, the spacecraft New Horizons flew past Pluto after a journey of nearly a decade. What it revealed changed everything. Instead of a dead, frozen sphere, scientists saw a world alive with movement, structure, and surprising complexity. Pluto's surface was not ancient and heavily cratered as expected. Large regions appeared geologically young, fresh, reshaped, possibly still active today. Almost overnight, the idea of Pluto as a static relic began to collapse. At the center of this transformation lies a vast region called Sputnik Planitia, a giant, heart-shaped basin dominating Pluto's surface. At first glance, it appears to be a smooth frozen plain of nitrogen ice. But this icy sea is anything but simple. Sputnik Planitia stretches hundreds of kilometers across, filled with slowly flowing glaciers of nitrogen, methane, and carbon monoxide ice. These glaciers move much like ice on Earth, creeping over immense spans of time. Scientists realized they were witnessing active geology on a world once believed frozen solid. And the mystery deepened. Evidence suggests this massive basin may have changed the way Pluto spins. Its weight could have shifted Pluto's orientation through a process known as true polar wander. In other words, Pluto may have reoriented itself because of its own frozen heart. But perhaps the greatest mystery lies beneath it. Many scientists believe Sputnik Planitia may sit above a hidden subsurface ocean, a buried layer of liquid water trapped beneath kilometers of ice. Despite Pluto's extreme distance from the Sun, heat from radioactive elements inside its rocky core may keep that ocean from freezing completely. If true, Pluto is not just an icy shell. It is layered. A frozen crust above, a liquid ocean below, and a rocky core at the center. That possibility transforms Pluto from a frozen relic into an ocean world. And ocean worlds change everything. Because on Earth, wherever liquid water exists, life tends to find a way, whether near deep-sea hydrothermal vents or beneath Antarctic ice. The idea that Pluto could host a hidden ocean raises a profound possibility. Even the distant outer solar system may contain environments potentially suitable for life. Not proof. Not evidence. But possibility. Pluto's surface offers more clues. Vast fractures, ridges, and fault-like scars stretch across its crust, suggesting it is slowly deforming over time. A world once thought frozen appears quietly evolving, alive in geological time. Then there is Pluto's extraordinary relationship with its largest moon, Charon. Not merely a moon, but almost a partner world. Instead of orbiting like a typical satellite, Pluto and Charon revolve around a shared center of mass located in space between them. A binary system, locked in gravitational balance. This cosmic dance may help generate internal heat, possibly contributing to the survival of a subsurface ocean. And Pluto's atmosphere adds yet another layer of surprise. Thin, fragile, and constantly changing, Pluto follows an elongated orbit that takes 248 Earth years to complete. When it moves closer to the Sun, surface ice turns into gas, forming a temporary atmosphere. As it drifts farther away, the atmosphere freezes and falls back to the surface like snow. Few worlds behave this way. Within this fleeting atmosphere, sunlight drives chemical reactions, forming complex organic molecules known as tholins. These compounds settle onto the surface, giving Pluto its reddish hues. They are especially intriguing because they are linked to prebiotic chemistry, the kind that can produce life's building blocks. And above it all, Pluto's sky reveals something unexpected: layers of bluish haze suspended high in the atmosphere. When sunlight passes through them, Pluto glows faintly blue, a delicate, structured sky where none was expected. Karen tells its own story. Its surface is carved by enormous canyons, evidence of past internal activity. Near its poles, reddish stains suggest material escaping from Pluto may drift across space and freeze onto Karen's surface. The two worlds may even exchange material, a chemical connection across thousands of kilometers. Pluto is not alone. It is part of a system. And beyond it lies the Kuiper Belt, a vast region filled with icy remnants from the solar system's formation. For decades, these distant objects were assumed to be cold and inactive. Pluto shattered that assumption. Because Pluto has shown us something remarkable: the farther we go, the less empty the cosmos becomes. And beyond that frozen horizon, even greater secrets may